Hi Bobcats, this is Miss Lee, and today's video lesson is on classifying rational numbers. Don't forget, take good notes as you're watching the video. Okay, the number system classifies numbers based on their type and characteristics. This Venn diagram shows the number classifications we will be working with in 6th grade. We will be working with the whole numbers, with the integers, and with rational numbers. So what exactly are these classifications? Well, the whole numbers is the set of all positive counting numbers starting with 0. These are the numbers that you learned about when you first started doing math in elementary school. Some examples: 0, 1, 2, 3, 4, 12, 17, 28, 154. These are all examples of what whole numbers are. Then we have the integers. We just learned about the integers a few days ago. Integers are the set of the whole numbers and their opposites. So if whole numbers are the positive counting numbers, then the opposite would be the negative counting numbers. So an example is going to be the positives, like 1, 2, 3, but also the opposites. -1, -2, -3, etc. Those are examples of integers. And then we have the rational numbers. So you've actually worked with rational numbers. You just didn't know that they were called rational numbers. But rational numbers are going to include all of the whole numbers, all of the integers, and any number that can be written as fractions, terminating decimals, and repeating decimals. So let's talk about these. We know what a fraction are. Example would be 3/4. That's a fraction. 7/8. You could also have a mixed fraction or a mixed number like 2 1/2. Okay, those are all fractions. And then we have our decimals. Terminating decimals, just like the word terminating means, to terminate, to end. Okay, an example would be 0.25. It stops. Okay, so 0 and 25 hundredths. You could have 0 and 125 thousandths. You could have 3 and 64 hundredths. These are all terminating decimals. Versus a repeating decimal. A repeating decimal is where part of your decimal value repeats over and over and over again. That decimal number never stops. For an example would be 0.33333333333333333. The 3 keeps going on and on and on and on. It doesn't stop. So to write that, to represent that, it'd be 0 and 3/10, and it's this 3 that repeats. So to show that it repeats, we put a little horizontal bar above it. That's the repeat bar. When you see that bar above the number, that means that number is repeating, and it keeps going on and on and on. So it is a repeating decimal. It doesn't terminate. It doesn't stop. You could have more than one digit repeating. You could have 0 and 24 hundredths with the repeat bar. And that means that the 2 and the 4 repeat over and over. So it'd be 0.242424242424, and it goes on and on and on. It doesn't end. Okay, that is a repeating decimal. So we have the terminating decimals that come to an end, that stop, and then we have the repeating decimals that some part of the decimal number repeats over and over again, and it doesn't end. Okay, those are all considered rational numbers. So when I look at my Venn diagram, I know my whole numbers are my positive numbers and 0. And I know that they're part of my integers. But my integers, in addition to the whole numbers, they also have the negative whole numbers. And then the rational numbers, they include all of these. They include the whole numbers, they include the integers. But then this is very special that you need to know. They also have the parts. The fraction parts, the terminating part, or the decimal parts. Okay, there are no parts in the whole numbers. There are no parts in the integers. So any number that you have, if it has a part, whether it's a fraction part or a decimal part, it's going to be a rational number. It doesn't matter if it's a positive or negative. If there's a part, it can only be a rational number. Okay, so what I'd like for you to do is to pause the video and make this Venn diagram on your paper and we are going to go back and place the numbers in the correct classification. Okay, 75, that of course is a positive whole number, so it goes in the whole numbers. -3, it's a whole number, but it's a negative, so it can only go in the integer classification. 3/4, up, that's a fraction, that's a part, so it's going to be a rational number. 0 and 35 hundredths, again, it's a decimal, it's got a part, so it can only be rational. 101, that's a good old whole number. Coming over here, we'll start down here. -2 and 5/10, it's got a part, but it's a negative. Just because it's a negative doesn't not mean that it's an integer. Because it has that part, it makes it a rational number. -8, it's a negative whole number, that's an integer. 7 and 1/5, it's a mixed number, it has a part that can only be rational. 14 and 1/10, the same thing. It's got a decimal part, it can only be rational. Then we have, I'm going to skip up here to 0. 0 is just 0, it's not positive, it's not negative, but it's classified as a whole number. Then our last one, 16/4, that looks like it's a rational number because it's a fraction, right? Well, it is in fraction form, but you have to be careful. You have to make sure you're simplifying your fractions. 16/4, I can simplify by dividing both the numerator and the denominator by 4, and it gives me 4/1. And any number written over 1 can be written as the whole number 4. So although it looks like it would be a rational number because it's in fraction form, it's actually better classified as a whole number because it simplifies to 4 whole. Okay, moving on, last part. We're going to be giving these statements and we have to tell if they are true or false. Okay, so whenever I have problems dealing with, is it an integer, is it a whole number, is it a rational number, I like to make a quick little Venn diagram off to the side of my paper like I have here. And usually I'll just label like a W for whole, an I for integer, and an R for rational. And it kind of helps me visualize it better. So the first statement says all integers are rational numbers. Okay, so I'm going to look at my integers. Here's my integer circle. And it says these are all rational numbers. Well, that's actually true because the integers are inside of the rational number circle. So they are all part of rational numbers. All integers are whole numbers. So now I'm comparing integers with whole numbers. Are all of the integers whole numbers? No, because whole numbers are only positive. Integers include the positive and the negative whole numbers. So that statement is false. Some rational numbers are integers. The clue word here is some. So here's my rational numbers, here are my integers. Are some of the rational numbers integers? Yeah, they include the integers. They have more than just the integers because they include all of the parts as well, but they do include the integers, so this one is true. No positive numbers are integers. Well, that one's false because we know that the whole numbers are positives and they are part of the integers. And our last statement, a rational number is an integer. So if I pick any rational number, if I pick 1/4, is that an integer? No, that statement is false. To make it true, they could say some rational numbers are integers, but not any rational number. Okay, good job, Bobcats.